Yeah, it's the big Rock Candy Mountain. It's a peak in Utah. Sure. So that's why this is nice that we're like live streaming. People can watch. I don't think so.
Yeah, it looks it's from the left.
Wow, the weather tablet's really lackluster.
22 seconds.
All right, quick. Pascal had CSS.
Yeah, exactly. Yeah, that'll make it easy.
Now we'll never know.
Yeah.
Really good job.
Alright, let's see about playing this. Cool. So, you guys have actually about 5 more minutes to just get nervous.
Okay.
Because I'm going to talk a little bit.
Perfect.
Alright. Hey, my Autobot guys, come on over.
Autobots, roll out.
They're auto something, I don't know what they're auto of. But, cool. And my tiebreaker showed up, Nate. You're the tiebreaking judge.
Oh, these Jesse?
No, stay.
Yeah.
All right.
You're okay.
Okay. Okay. Last minute planning on who's saying what. All right. I'll have to do that. Cool. All right. Let's go ahead and get started. So Space Apps Reno 2016 is almost in the books. We got like maybe an hour left, right? So it's been a long haul. It's been fun. And now we're going to do some demos. You guys have been working hard all weekend. So you're going to demo your projects, kind of explain, concept, team, what you did, show us some software. That would be totally awesome. And then we'll have a little quick powwow, judging-wise, and talk about what happens after the hackathon. So, kind of put it in perspective here. This is a picture of the current NASA's map of all the sites the cities participating in the competition this year. So you can see that it's global, and we're not the last, right? Hawaii is the last time zone to finish this up. That's the blue guy out there. When we started this 4 years ago, we were the only city on the West Coast. So now we have some competition on the West Coast. And the orange icons signify that we're live streaming. So we're live streaming. So you're on camera now. So just smile. Cheers. And so it's perspective-wise. Last year it was 14,000 people participated, 140 odd cities. So we'll probably hit those numbers again.
I counted them. It was 162 2 weeks ago.
Yeah. Okay. So 162 and
2 weeks ago.
1,000 people per city. I don't know what the numbers are, but for growth year over year, in terms of this event, we've tripled, right? The number of people participating, signing up and whatnot, which is good. With zero marketing budget and me just going, hey, why don't you come to Space Apps? So the way that the NASA competition works is that we can nominate 2 projects for the global judging and 1 for People's Choice, and thus we have a problem this year we kind of haven't had before, which is we have more projects than things we can nominate. So so I had to recruit some judges, and can you guys just stand up and just introduce yourself real quick? So
I'm the only judge of the competition. I was the only judgy person there. I'm just totally young. I'm Todd Colgrove, the head of this library. Proud to be part of this.
Okay, Lauren?
I'm Lauren Klein, and I'm a management consultant. So nice to see all of you. I also own a local company called Girl Made.
All right, and one of our sponsors.
I'm Kathy Ray. I'm Dean of the Libraries, the De La Mare. I work with Todd and also the Knowledge Center.
Oh, great. I didn't know that. All right, so the other opportunity that's new this year is NASA has this open source innovation project, and we can nominate 5 projects from this location to be featured on their open innovation site, which is If you go to the portal, you'll see that they host data repositories, and they host code and working software that you can use as open source. It's a fun exploration to go in there. All right. So, quick word on sponsors. So, City of Reno was been sponsored. Came back this year. They were gone for a year. Now they're back. Obviously, the library for facilitating the venue. EDON has been a sponsor since day one. I had a conversation with Doug Irwin and said, "Hey, I need some money for this event." And he said, "How much do you need?" And I gave him an amount, and he said, "Well, I can give you this much." So, so it's fun having those conversations. GirlMate obviously has been doing the social media guerrilla marketing campaign over the last 3 weeks or so. Microsoft, we kind of partnered up with them, and we have a learning experience there, so we'll work on that. Reno News and Review, I always do an in-trade kind of thing, so they put a nice ad up for us. Pebble's been a sponsor since 3 years ago, and they give us stuff to give away. In the past, they've given us things to hack on and refurb hardware and stuff like that. Punch Through was another sponsor this year. It's a new one. They make Bluetooth Low Energy sensors, which 2 of you got those as raffle prizes. Planetarium hosted our pre-event, and Dan's the inspiration for one of the challenges that we actually continued working on this year. So, and we'll get to that when it's presented. My nonprofit, which is how I run this thing, STEAM Initiative, and then NASA for organizing at a global level. So, big names, small names, and then all you guys come together and make it happen. So that's the best part of it for me. So, all right. So now we're going to launch into the demos. It's kind of the order we're going to go in, and we can see that Don't Crash Me Bro is ready to go. So I'm going to give you 8 minutes, and we won't be like crazy like the Microsoft guys, and I'll start clapping when I want you to stop talking. but kind of respect the time. And then a couple minutes for questions, judges, anybody in the room, and then kind of wrap it up and move on to the next presentation. So go for it.
Yay.
Don't crash me, bro.
Come too. You're part of the team.
I guess. I need to get my part working. We're gonna, block the board that we made.
Yeah, right? It's all part of the fun.
So we are Don't Crash Me Bro, which was one of the NASA suggested challenges. It was, the idea behind it is to create an app and be able to have private and commercial drone operators figure out where they're in a no-fly zone, but also report like weather hazards like the wind that we have today. And we wanted to kind of expand it out to also include terrain data, so that way the drone doesn't fly over water and then run out of battery and fall into a lake. So that was the general gist of what we wanted to do. So we broke it up into 3 parts that we worked on over this weekend. The first part is the back-end server side, which is the handles the drone location updates and aggregates all the data from all the different sources. Some of the sources we pulled from were Google Maps, NOAA, and the FAA. So we pulled from all those different sources to get stuff like locations of airports, temporary no-fly zones, and Google Maps gave us some terrain data, and of course NOAA gave us weather data. And then we put that all into a RESTful API that's running on the laptop right now, and we were working on getting it to run on a Microsoft Azure server. We didn't quite get that running. The main piece is our app, Droner. Taking taking cues off of Tumblr and Untapped, where you remove the last E. And this app is running on that. And the laptop that I closed that killed the server. That's.
I can put that tablet up on the screen if you want.
Can you now?
Yeah, magic.
We have the technology?
Yes, we do. As long as it doesn't take more than 8 minutes. Just kidding.
So this is kind of the actual display piece. We did get it running cross-platform on iOS and Android using Xamarin, which is now owned by Microsoft. And
we actually ended up using Ionic.
Ionic, okay. So we used Ionic then, which is built on Cordova. And so this is where it displayed.
Still working on getting it up there.
Yeah, sorry. Should be faster than this. Started recording my home screen. Okay, maybe we can.
No?
That's fine. One more try.
Go ahead and talk about the simulator that you have.
So then, the last piece was the drone simulator, which is running on my phone, which we did build with Xamarin. And basically, because we didn't have any drone hardware to experiment with, we weren't able to really figure out what communication protocols were there that we could facilitate between a drone and an app. So we wrote a quick, but it took me all weekend, simulator that runs, that pulls GPS coordinates off my phone and reports it to the server, and then the app uses drone ID and is able to pull info about the app, where it is. So for our demo,
so here we've got the app is showing the map of where it thinks that the drone currently is. It's nice and big because it wouldn't go up on that screen. So as he changes where we are on the simulator, then you're going to be seeing the location on here update shortly after. And so right here around Disneyland, because Disneyland is a happy place, we see that we've got a no-fly zone marked out. All of the data that we're using right now is actually mocked partially because we're pulling from random locations, and we had a paid public or a paid key for the weather app and incomplete data for all the no-fly zones. So it's mocked data, so we would like to go live with it, but that's always terrible in demos. So we can see that there's a nice no-fly zone over the area, and it recenters. And now we've already all of a sudden teleported to Reno, where there's a radial no-fly zone over the airport, and then we created a little additional no-fly zone in the downtown area, just as an example of, hey, here's multiple things that could be going on. We also have super tiny and super unformatted because we ran out of time and nobody's awesome with CSS and making things look pretty because we're developers. But as you can't see on this page, we're displaying all of the weather information that's currently going on in that location as well. Any hazards that are going on provide links to a website to get more information about them. And we've got the current temperature, wind speed, wind direction, gusts, visibility, things that might be important to know if you're flying a drone around the area.
So then, like Rob said, we're using mock data. So that is part of our things we can do better section, which one of the things that we would like to have done was test with an actual drone, or have firmware, because then that goes into the last part, which is one of my original ideas was if it entered a hazardous area or if it detected that weather was going to be happening, the drone could set itself down safely and then be picked up. Or if it went into a no-fly zone, it would then bug out and fly back home. And the last one was real-time weather and no-fly zone data and all the other stuff that we couldn't quite pull off. We did have all of it pulling at once, but then with the paid token, we didn't want to accidentally publish that on the internet, so that's it.
All we have.
All right.
All right.
So,
Questions?
kind of open it up for questions.
And we'll be available right there if you'd like to see the apps.
Maybe if I might, so if I'm understanding it, then your vision would be that the app droner would be eventually incorporated perhaps into the drone operating system?
Yes, the idea was that then it would communicate with the firmware, and then the firmware would be able to detect when something happened or bug out. Another thing that we had talked about was they have the first-person overlay for drones, or video overlays, and we had talked about displaying it also on there. But with the weekend, and so.
I love it.
Yeah.
It's like ways for drones.
Yeah,
Mhm.
Interesting.
Yep.
Basically.
All right, anybody else?
Wouldn't it require drone manufacturers to input different sensors on their drones then? Like if you're talking about some of the real-time weather?
The real-time weather we were going to have just from the National Weather Service.
So all we really need is the location of the drone, and then we know all of the data that surrounds it, all of the environmental data.
And other than that, the rest of what the drone would need to communicate is in most commercial drones.
All right. Well, thanks. Don't crash McGraw. All right. Next up, we have Canary, and Canary's ready to go. So, okay.
I'm Ashley, and this is Andrew, and he's going to be my model, so he probably won't be talking very much. This is our third year doing space apps, and every year we end up doing something that's hardware-based, which doesn't ever seem to be actually a challenge, but we kind of make it work for our ideas. So our project this year is called the Canary, which is based off of the phrase "a canary in a coal mine," and it's in response to the Air Check Challenge by NASA, which is to aggregate live air quality data and kind of cross-check that with information about people who suffer from respiratory issues. So our concept was to make an actual wearable device, aside from just making like a web app. I personally have asthma because I was exposed to a fire when I was in Lake Tahoe as a toddler. So the fact that people are exposed to bad air quality is something that pretty much every community experiences. So we're really interested in the idea of making smart fashion. So we decided to try to make some sort of wearable hood, with the vision far out being that it would be like a full jacket that someone would be wearing when they're out exploring their town or whatever. So within the hood there's a light strip, and the light strip uses live air quality data and changes color based off of the air quality gauge that's set by both the Earth Data Worldview database as well as the Air Now API, which the local Washoe County Air Quality Department uses to kind of share information about what the air quality is. So it's a little hard to see, but within here there's a light system, and it'll initially alert the user based off of the air quality that it detects, and it has a compass within it using live GPS that will help steer the wearer to a safe air zone. So for instance, if I'm out in the community and there's a fire and I have asthma and I need to get somewhere that's safe, it'll help kind of direct me to a place where the air quality is a little better. And there's also an air, like a mask within it that our vision was to have like an air filtration system within it. So if you are out in the city and there is a fire, but you can't get indoors right away, your wearable device would help kind of filter the air for you. So we used an Adafruit Flora, which is a little wearable microcontroller, which is used for wearable devices. And we kind of simulated some live data, but we did use actual live air quality databases. The beeping is it resetting every time. So we just wanted to simulate what it would look like if, for instance, the air quality was bad outside, and how it would attempt to steer the wearer to a safe air zone. So that was our main hardware, and our data sources were from NASA's Earth data, and the rest we just kind of simulated for the time being. Yeah. Cool.
Awesome, awesome. All right, we have a few moments for questions, so fire away.
Any questions?
Yeah, Tom.
The question I have is, so when you're plugging it in, then it's firing up red, that's simulating that you've got bad air quality, and then it seems to tone down. Is that because it's actually operating live from your simulated data?
So the simulation would be you hear the chime indicating it's bad data, you put the hood up, and then as you go into a space with better air, it turns to a different color and then navigates you to where the air quality would be better.
So is the Flora actually driving the bus right now, or is it pretty much just...
Technically, it's using real data, but we simulated it just for the presentation.
I don't have any GPS right now
Yeah.
in this building.
But the idea would be, and it wouldn't be tethered. The idea was it would be a full standalone device that would be using real GPS outside and reacting to that. We did get it working, but not in the building.
So a quick question. So
Yeah.
the power source, how do you see that working out? Is it a battery power source, or is it?
Yeah.
How does that look?
Right now it runs on 5 volts, but we would need to put some kind of radio for data to
Okay.
communicate. So right now it's running off the wireless and the power source of the...
Yeah. So it's self-contained in that it has its own ability to collect the data in terms of radio capabilities.
If we had a different microcontroller, yeah.
Yeah. Okay.
Totally.
Interesting.
Yeah.
Okay. Cool.
And so will it be voice recognition for the navigation?
Right now it's just light, so just a visual. But
So you can, it's compass directions.
so there is a bright light that, like if you had a compass, it's steering you toward the direction you need to go in. So there's no voice recognition, but that could be a useful feature.
I'm thinking about future functionality
Yes.
to commercialize.
Yeah.
and
Totally.
MVP, so.
Totally.
There you go.
Yeah. Yeah.
So you're saying the light acts as a compass?
Yes. There within the hood there are a few pixels that are brighter than the rest of the strip, and they move based off of where you're being navigated to. So like when you're holding a compass and the needle is pointing you to the direction that you need to go in, which would be north, this would navigate you by moving the light around.
Yeah, like in a video game, when you have that waypoint that you're trying to hit, the light will move around the.
Yeah, I got you.
Yeah.
Exactly. Yeah.
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 So from an audience analysis perspective, I mean, this use case is for like an individual with a known set of respiratory, but what about the applicability for an audience such as firefighters?
Oh, totally. That's actually the concept, and the name Canary arose actually a few years ago when I wanted to make this, but I wanted to make a device specifically for emergency responders. For when they go into dangerous areas, it kind of is like an all-purpose sensor for any sort of dangerous environmental factors. But this was just more because we want to wear cool tech fashion out in the community. This might not look super cool to the rest of you, it does to us, but the goal is to make like smart fashion for everyone, because I feel like if you're wearing a jacket, it's protecting you from wind and rain, and why not air quality as well?
Right, so when I think about use case for impact for societies, when you look at the military or emergency response
Totally.
system, let alone the American Lungs audience and the other potentials if you're going to help direct individuals that might be blind or
Sure.
have other types of disabilities, it's quite interesting.
Yeah, absolutely.
All right. Anybody else? All right. Thank you.
All right, thanks.
All right. Fetch a rock. You want? Yeah. Okay.
You just want to point at me? No, go next.
You?
Alright, so our group addressed the problem that NASA proposed on trying to map out a method for potentially carrying out mining operations on asteroids within our solar system. And although right now this isn't really a feasible thing to try to achieve, because we don't really have the technology for getting there or bringing material back, it is something that a lot of people have started to look at because it is potentially extremely lucrative. So for an example, this is a website not affiliated with us, we didn't have anything to do with it, but it's called Asterank, and it's a map of all known asteroids in the solar system with their potential worth from mining materials. So as an example, this one out here is listed at about $25 million trillion in money, if you could mine that. So lots of people have started to look at this to try to get a jump start on the game. And our approach was to look at really three main points. If we were to carry out this, what would we have to address? So one's the production of energy. You have to get a rocket to the asteroid, and then either you have to bring the asteroid to you or just bring in the material to you. So you need a lot of energy to do that. Transport, that's in the same category, and then also elemental detection. If once you get to the asteroid, where do you mine most efficiently? What can you pull out of it? And also look at asteroids in the neighboring area. So to talk about the transportation, Jeremy will do that.
All right, so basically, yeah, I was tasked to kind of design the rocket that would land on to the asteroid. And so what I came up with is a couple of stages. So this is how the rocket will launch from Earth. Okay, so it's normal, just with any space shuttle, it would launch like so.
Oh, we're back.
So yeah, I animated this just to show quickly what it does. So the first phase is that once it enters orbit, the second phase starts. This breaks off. This has it's a nuclear impulse type of nuke, basically, and so basically this will embed itself inside the asteroid. Here are some aerojet thrusters that kind of guide it. The tip will start to open, and it will make contact with the surface of the asteroid. This exposes four auger bits that will drill into the surface. The four, I chose four so that it would stabilize it. It would pull and sandwich the surface and this portion of the rocket. Once it's locked on, then the nukes in the back start firing off, and it starts pushing the rock into orbit or whichever direction. We thought that this was this two-step process was the most beneficial because one, the nukes, obviously we can't launch nukes here on Earth. Why not do it in space? So that's why there's the two stages. And Ben will explain why nukes are so important in this.
So as Jeremy mentioned, this project works off nuclear pulse propulsion, which was a method investigated by NASA a couple years back before the test ban treaties. And so primarily our inspiration came from Project Orion, which is illustrated here in the artist renditioning. And the reason that you have to do a method like this is you cannot get this type of power out of chemical propellants that we currently use. So you need something that is small, doesn't take up much space, but dishes out an enormous amount of energy. So this is where the concept of fusion comes in, which is most commonly used in thermonuclear weapons, where most people know about it. But it doesn't have to be something that's designed to destroy. So instead, it's just the combination of two atoms. Here it's deuterium and tritium, which are both isotopes of hydrogen. So they're both just forms of hydrogen, which is very abundant. And what happens is when you fuse them together, you form helium, as well as some radiation, but you also get an enormous burst of energy from that. And so it's that burst of energy is what we're using to propel our spaceship, and eventually to lock on to the asteroid and bring that back to Earth. So we created a simulation to do this, and this is physically accurate, and we can calculate also the required amount of deuterium and tritium to bring an asteroid back into orbit, and Colin will talk more about the simulation.
Yeah, so I don't think you'll be able to see this very well. Show and hide all that. So what we did was we made a software simulation that actually shows the orbit of the moon, the Earth, and an asteroid of our interest. So if we start this, it's a little bit hard to see from a distance, but we've got the Earth in the center, and then there's a dotted line that predicts the orbit of the asteroid. So right now the asteroid's actually going to come back into view. I don't know if there's a light switch somewhere.
No. we've been down that road.
And then what we can do is we can actually click around. So if I click on the asteroid, it'll actually fire the thruster that we have landed on the asteroid and change the predicted path. So every time that I thrust, you'll see that now the asteroid is closer to Earth, and I'll just move my mouse as to where it's going right now. But it actually predicts into the future where it's going to end up and allows us to essentially simulate what we can't actually simulate this weekend by putting something into space. So, and all of the math there mostly checks out for putting multiple bodies in space and having them interact with one another.
So I'm going to talk about how we can determine if the orbit is stable. So in binary systems, it's really difficult to find a stable orbit. So one of the solutions to this is place the asteroid in a distance from the center of mass of both Earth and the Moon. So that way we can come up with a circular stable orbit outside of the Moon's orbit. But it's not the best solution because it will be still too far away from the Earth. So we got to still get there and mine it. So what else we can do? We can put the asteroid in between the Earth and the Moon in an equilibrium position, which both forces of attraction, both force of gravity, gravitational acceleration will cancel out, and it will stay stable between Earth and the Moon. So we can plan trips from Earth to the Moon, passing by the asteroid, mining it, and then coming back from Moon back to Earth. So a round trip while mining.
So lastly on that list was elemental detection, and because we've landed a thermonuclear device on top of an asteroid, that is also a source of intense radiation, and so that is commonly used, something called X-ray fluorescence, in doing elemental detection of materials in the ground or just an unknown sample. So the way that works is you have some source which emits a broadband spectrum of radiation. Basically that just means it has all the energies in it. It's not at one specific thing. And if you send that broad spectrum of energies through an unknown sample, you're going to get out of it specific signatures. And each element has its own separate specific signatures to it. And so by flashing it with a bright burst of X-rays, you can look at how it reacts, what spectral signatures you get out, and determine what is where on the asteroid. I don't know who's talking about this part.
That's all right, we can keep going.
All right, yeah.
I think we're over.
So then
Yeah, you're a little bit over.
use some math we're good, yeah.
Nice.
Thanks to AstroRank, the one that I showed you, Skyfield and U.S. Naval Observatory, and London Metal Exchange for doing some price analysis on asteroids. We have goals and stuff in the future.
We have goals. All right.
Thank you.
Good job. Good job. Questions?
How big are these asteroids, the ones within your ray? I mean, compared to the moon, how big are they?
Much smaller than the moon, but they can vary between a large bus to something on the order of the moon. Not quite as big, but yeah.
So did you do the analysis of time to mine? I'm trying to think of like the ROI as an investor.
It's
So-
terrible as an investor. Unfortunately, the values of these things when we look at them are so high, but the cost to mine them and the time to mine them, you may not end up with anything on it right now.
Right
That's
now.
where that's the issue.
It would be enormous. We didn't go down that path to really figure out how long it would take to payload size, say how much material you're actually going to be able to bring back, how quickly. We didn't look into that yet, but
AstroRank does rank them by estimated value as well as ease of potential access, and it even shows the dates that would be the best time, and you have very small window of time to catch these and put them into this orbit before we have another 40 years for some of them, another 2 years for some of them to do it again. So it's
I would
very
imagine like Google X and the Google Prize and the SpaceX groups, the R&D arms would probably be quite interested in the time to mine estimates.
could definitely be, yeah.
A couple of questions. So, if I'm understanding you right, you're imagining basically hauling them into a liberation point somewhere between the Earth and the Moon.
There's a couple options. There's other stable orbits which can exist around the Earth. If we can get into a circular orbit, there's ways that we could figure that out. You proposed, there are ways of getting it maybe even into sweet spots in orbit where it would just be much easier to access. But I think there's a range of possibilities which we can simulate now given our code.
The part that I was trying to wrap my mind around, and maybe it was just cut off at the end. The concept is that you're basically landing and drilling into the asteroid with a device that regularly detonates thermonuclear bombs. How are you imagining getting the absorption spectrum of the cloud? Are you drilling stuff and blowing it out into the asteroid and the Earth, or where would you get that far?
So you would be limited basically on the depth because of given the penetration depth of energetic photons, it could not be very much in some materials. So you might just get a surface analysis of looking at a mountain, and if you can find certain veins or something that might be exposed, you can get an idea that way. As far as getting something where it's a more deep look at what the core of it's made out of, there are also ways to do that. They're more complicated. That is also limited by technology right now and our detection abilities. But
Envisioning this as a real project, a real investment, would you imagine perhaps probes that were going out and searching a variety of these into the spectrum, giving you your ROA so you can come back?
could definitely do something like that. So ideally, you could send out little scouting rockets first to latch on and give a sample. I mean, we have some idea of what the asteroids might be made of from data that exists, so you can pick maybe your best guesses, and then once you land there, do a more in-depth analysis of what exists.
Sorry for asking all these questions, but who did the orbital mechanics?
I did.
Well done, sir.
Thank you. And so it does have the ability right now to extend out to the solar system, so we can pull in all the data almost in real time, so we can go out and we can hit a website, figure out where all the planets are, we can start the simulation, and then ideally we can also pull down information on those asteroids too. So we can select an asteroid off the AstroRank site and then figure out what the predicted cost might be to bring it in by calculating how much fuel we're expending using the thrusters. And I should also mention, sorry, the nuclear thruster that we used for the code was developed by a professor here at UNR, Professor Friedbart Winterberg.
I'm thinking about it, if you couldn't bring it into stable orbit, so you're trying to, not that there's anything wrong with your math, but worst case scenario, what happens?
Well, then you have a rocket that is full of fusion fuel, which you crash into the Earth at high speed.
Okay, that was
There is another solution that we can apply. For example, from the International Space Law, we cannot have any celestial body. Like, for example, US can't declare moon for itself, but we can crash the asteroid on the moon and mine it from there. So that's also a possibility. Worst case scenario.
Other option is Bruce Willis.
Armageddon.
The simulator does eventually, if you do it wrong and you thrust in the wrong directions, it will simulate impacting the Earth.
Yeah.
And we're better.
And did you look into what the B612 Foundation is doing?
No.
It was started by Ed Lu, who's an astrophysicist and NASA astronaut, and they're actually launching these, they call them Sentinel satellites. I think 2018, 2020, they're launching these satellites up on a SpaceX rocket, and they're going to do just that. They're going to start scouting for these asteroids and figure out how much they're worth using spectrometer and stuff.
It's something that lots of people are really starting to take a closer look at, especially as we're rapidly losing materials that we have on Earth to mine and use. And so in the future, and possibly even the not too distant future, it can not only be extremely important to go out, but a necessity to go out and mine objects in space.
I have a question for clarification. So the data that you're dealing with here, this is actually an API, so you're pulling from NASA.
For the stuff that we just showed, it was just a randomly generated moon. The physics is there, but we don't have the moon in its starting positions if we were to start now, where is it? However, we do have the capabilities to do that. We just didn't get it working for this demonstration.
All right, there's no more questions. Great job. Awesome. Biggest little solar system in the world.
So, Biggest Little Solar System is actually an extension of the project that I was on last year. So last year, several of us figured out the orbital mechanics to determine the current real-time position of the planets and made an API. So this year we've created a game based around that API. If any of you have played Ingress, it's a little bit inspired by that. So the general idea is that you can walk around, well, I suppose I should rewind a little bit, the idea from last year. The planetarium here at UNR, the dome is painted to look like the sun. So Dan Ruby, who runs the planetarium, proposed the question, if the sun were that size, how big and where would the rest of the planets actually be in Reno? So we answered that question last year, and then this year we're making a game on top of that. So as you walk around Reno, we've got the solar system plotted on Reno, and you can visit the locations where the planets are right now, and we're also plotting the orbit so you can see where they will be in the future. And then once you're at a planet, you can, if nobody has claimed it, you can claim it for yourself, add some defense satellites, shields. We haven't gotten into the specifics of much of the gameplay yet. And then so if somebody else has claimed it, you can attack it, take down their defenses, claim it for yourself, etc.
Do you wanna? Okay, so I just you can see I just sort of reinforce my defenses around this planet. Venus.
Which one is that? Venus?
You can see, so Chris over there is gonna. There's we also have a web client. And he's attacking it right now. You can see the health is dropping. And he's taking down my defenses, and he just took over control of the planet.
Nice.
And then so right now, like the distance, you have to be like in close proximity to the planet in order to like attack it or fortify its defenses. I think in practice that would probably be like what are we talking, like 250 feet, 75 meters. Right now it's set to a lot bigger than that. It can be hard to demonstrate otherwise. But you can see like some of these planets, like
where's Pluto?
Pluto is
some of the dwarf planets are actually even farther out.
Pluto is right out here, over by Lake Tahoe.
Nice.
We added all 8 planets, all 5 dwarf planets, and then 4 of Jupiter's moons, Titan, which is, I want to say Saturn, and then the Earth's moon. It's like if he zooms in on Jupiter, you can actually see the orbits of those moons as well.
I zoom way in before the others.
Yes.
Oh, nice.
Oh, cool.
And then those are also, you can put satellites around the moons and have the same interaction with those as you do with the rest of the planets. He's not close enough.
Yeah.
So right now it just has the planets and the basic functionality. One of the things we were talking about is in order to put satellites or to attack with missiles, you have to first build your satellites and missiles. So we were going to add some asteroids, potentially using the database that the other team mentioned, so that we can have more actual real-time information in it. So it's not just random things, it's actually based on reality. You know, you can find an asteroid, mine it for some materials so that you can build whatever it is you need to attack or defend your planet, so that you can build it up in an educational way. Anything else you want to add?
No, I think that was summed up.
All right. Awesome. So, questions?
Yeah.
Are you looking at commercializing advertisements or for individuals as they're passing by the planet?
We hadn't really taken it that far, but at this point the project is open source, so probably not.
There are some other things that I've thought about that involve this project, but we're not going to talk about them here because it's not the focus of this. So.
Is that API being used for anything else?
Not at this point. It's been out for a year, so it is available if anybody wants it for anything.
So
the original API we made last year, it doesn't do GPS coordinates, it just does distances in X and Y. So you can, you pass it in the scale, which in this case we're scaling it to be the UNR, or the planetarium sun, but you can pass in any arbitrary scale and it'll tell you how far and in what direction to place all the planets. It's like if you're a teacher and you're doing something on a basketball court, you've got this much space for your biggest planet, and it'll tell you how big and where to place everything. And then now this one adds GPS to that.
When you say it does that, does it do it in a manner that would allow a teacher to quickly...
There's no nice, easy-to-use interface in front of it. It's just data right now, but it's not too far off from being able to do something like that.
Just thinking of Washoe County teacher.
Yes.
Yes. Yeah. Oh, yeah. That's.
But it would be just a matter of having a form where we plug in, this thing is this size, and it prints out a table of all the planets and their locations in that scale.
So the gamification strategy is really around predominantly, intrinsic motivators for individuals to get educated and learn.
We just like the idea.
So yes.
If we're going to build it out, we'll need to meet with some people who have more experience in actually building out and developing how it should work.
Yeah.
I see it as a good way to kind of, gamify to learn about the solar system and comprehend the scale and down to a manageable and understandable size.
That was another thing that I found fascinating is the dome is about 10 meters across. So at that scale, Jupiter is a meter, and the Earth is 3.5 inches wide. The moon is, a pebble. So it's just, and as you can see from the distances, they're extremely far away. So it's just eye-opening at how much space there is in space, how far apart everything actually is.
And light speed at this scale is what was it, 4.7 miles an hour?
4.7 miles an hour.
Like a brisk walk, slow jog, the traveling speed of light.
So you could use your phone like Strava and say you're going 4 times.
That was another thing we talked about.
Yeah, totally.
If you're traveling things, you can put your speed on you're going
So
warp 2.
After we did this last year, I went ahead and started developing business plans around some of the stuff you asked about. So I have a bunch of material that backs that up. It's just a matter of finding money. So.
You guys going to team up with the previous group to add resource gathering from asteroids for resources?
Very likely.
Yeah. APIs.
And I like it to be these things in it to be as real as possible. If we need more.
Do not disturb.
Real-time testimony.
If we need more asteroids than are available, we can throw some random ones in there. But it would be nice to have actual ones that are following the paths that they actually do.
Yeah.
We've also had some thoughts of adding an augmented reality view. So instead of just looking and seeing a map, you can actually hold up your phone and see where they would be.
Mm-hmm.
So when you walk up to them, you can
Try finding something 3.5 inches big.
Yeah.
Oh, that would be smart.
Just for my own understanding, the location of the planets and everything is basically relative and correct, but that's based on work that you did last year, or did you do some additional work?
The location of the planets was based on last year.
Okay.
We didn't have any GPS, so that we had to add it to it this year. Last year it was just meters in X and Y. This year we added the GPS and then gamified it, the graphics and the art, made the API a little easier to use.
All right. No more questions? Awesome. Autocar. I don't know if you changed the name, but you want the projector.
Oh, yeah, it's
Okay. You need
oh, we got a cable right here.
Oh, okay.
Lock it. Right here.
Keep push it. Foot to the left. Perfect. Nice. Source.
All right.
Yeah.
So, we decided to do a project called Autocar, and the idea is you take a tractor, which we have down here on the floor, and you combine it with an autonomous vehicle, and then you end up with this auto car idea concept. So what we did is we took a child's toy tractor and we decided to try and make it so it could function on its own, all by itself. And then the question is, why would you want to do this? You know, you don't want your kid driving in this. So one of the reasons that came to mind is, you know, you don't want to be manually, you know, plowing some fields by yourself if it can be automated. Another reason is the distance to communicate with the planets is so long that autonomy is the way to go. So that was kind of the concept and the idea behind this whole autocar vehicle. So the way it works is, if you can see up here, we have a computer with a camera on the front. We use computer vision to detect, you saw those crop rows, we detect lines and different markers so that the car can operate on its own. We used OpenCV Sharp, sorry. And then we also used some popular algorithms to detect these lines. And the idea is then we could release this vehicle into a field and have it do the manual labor that would be too dangerous for a human to do. So these kinds of vehicles are greatly needed. So I have a quick little video here to show you some of the computer vision stuff that we were doing. let me make sure, see if I can blow this up for you. So what we have here is some lines on the ground, and this could represent some lines in the field. And the first part of our algorithm is just to detect those lines, and then we also just trying to determine the center of the lines. And if this vehicle was pulling a plow or some similar apparatus, then that plow would also be controlled, and hopefully you would get straight rows. Otherwise, you're going to be destroying your crops, which would be a very, very bad thing. So here's the computer, and I'm going to pause it right here. If you see that, sorry it's a little blurry, there's a green line there, and that is the detected middle of the rows, and with the red line is the difference from where the tractor is to the center of the rows. So just as a demo, we moved the tractor back and forth. It's actually a laptop, but we move back and forth, and you can kind of get an idea. As the red line grows, you can see we're going to one side, and then as it shrinks, we're going to the other side. So this is how the tractor would maintain a center row in order to do this dangerous work on a remote planet. All right, so that was half of the project, was doing the eyes behind the tractor, and then the other half was how to get the hardware of the tractor to actually talk to the computer vision component.
You can just keep it going, and I'll just speak to it.
Okay.
So at first, we were using some embedded systems, and we first started off with a BeagleBone, which Rip, you know, he ended up passing in this experiment that we were doing. It was supplied by our Everett here, and so what we were trying to do is we had a node-based file that we were running, and it would potentially be listening on a WebSocket or something like that, and just be listening for any change or any data file that would be coming from the CV. And we got all of the direction working. We got left, forward, front, back. We got all of that operational, but unfortunately, the BeagleBone suffered. What was it?
Just a standard electrical short from touching two contacts that shouldn't have been touched together on accident. Let the magic smoke out.
And so, after that fiasco, we had to go over to the Raspberry Pi 3, which we thought would be a pretty straightforward, but just in the limited amount of time we already had a Python script that was already on the system, and so we stopped using Node and we tried going with Python, and we were able to get the same functionality with actual remote control. So we were able to, from a different computer, tell it to go left, and it would turn the wheels left. Tell it to go right, and it would tell it to the wheels to turn right. And if we said straight, it would stop, and if we told it to brake, it would brake. And so that was all via what wasn't. It's technically wireless. We were via a router, so it was close enough. The proof of concept is there. And if you want to talk about the other pieces of hardware.
The router is ideally going to be wireless for the Raspberry Pi 3, so that way we can have the communication completely indirect. And then for the motors, it's using just the stock drive motors that had come with it. They run at 12 volts and 230 watts, which is pretty powerful. And then I was using a old recycled tank motor for the steering servo, but we did have a backup stepper motor just in case if we needed to use that as well. The motor controller is a dual H-bridge by a company called Drock. They make our Apps Reno shields and H-bridges, and I just purchased that, and that's what's used for the left and right steering. And then all of the commands are sent through the BeagleBone or Raspberry Pi.
We have a little demo of that. Let's see. Here is the car being turned right. Watch those wheels, there it is. All right. So we had right and left going on too. I just didn't get it on video. But yeah, it was pretty awesome project. It's quite a lot to do,
and none of it was done beforehand. So everything we've done so far was all done on site.
Yeah. Except the computer vision we did a little.
Yes, a little bit of software.
Yep. And yep. So future work. We need to fasten things together, make it a little more robust so it can handle being autonomous, really far away. We also need to improve some motor control, maybe improve the steering and the computer vision definitely. Maybe do some PID control to prevent swerving back and forth. But all in all, we think there's a lot of potential for these type of autonomous vehicles on distant planets. So, do you have any questions?
All right.
So that's all we have.
Got a question?
First off, where did you get an H bridge? First thing to go up. Did you happen to have that?
Well, one I had purchased, the other one I tried to build, and that one didn't work because we had used the wrong kind of transistors. They were all 4 NPN. We needed 2 PNP and 2 NPN. So that schematic didn't work, and then we were just using the stepper motor controller for the secondary one.
And the other one was, when I'm seeing this, it's like, why aren't we doing this today? Are we doing this in any fields? I mean,
A few companies are doing something like this. Like Toyota does autonomous vehicles for farming right now. Yeah, but they're not going to send anything to Mars soon.
Thank you.
Yep. Awesome.
Source over here. Just hit the button, you should find it. Which one is it? Yeah, it should be cool. Thank you.
All right, resume. Oh wow, looks like they finished this in time. Okay. Next up is we as judges are going to go off and talk about these. Eat all this candy. Whatever you see on the floor, please pick it up, put it in the trash. You know, that good citizen stuff. So we'll be back shortly.
Does I show?
The annotation.
Yeah, a lot more than last year. There was really confident, like you could feel the whole vibe in the room.
No, yeah. So yeah, last year I got to see so many different pieces. There was the actual data crunching API. And then what I was working on was like the 3D.
Alright. Sit there and be apologetic.
Like I wanted to work on AR for it, but AR is really difficult to program. Augmented reality.
Oh, yeah.
It's really difficult to program. So I just kind of did the you'll scan it and you'll get all over the planet. So that's the piece that but I want some.
He said you will. So.
You're supposed to get it all done. What do you guys do? You all work together, or what three of you?
Yeah. Rob and I used to work together.
Okay.
Yeah, and then I moved to Sim Games where I worked for Chris. Kevin over there, and then obviously. So like all of our work group was spread out across the different groups.
Which only matters if 2 of the teams are going on. I work sort of publish as much as we can because everyone else should have them. I can go look at all the other apps.
Place going though.
Those of us in the same.
Yeah, I can copy that.
That's beautiful. So we
That's why like last year we didn't, Joe didn't put in any category. There was no space depression category or anything.
Because I can build that environment in a box or environment in a fishbowl. Did you see that? Sorry, weekend team that basically copied that. Yeah. Recreate the environment inside of
We were doing like, I mean, that's
I was like,
exactly. Yeah, it was an exciting.
That's funny, Lauren is like, you know how many people would think that out was real fast?
Yeah, that's what the judges were asking too.
Well, there's that one company
oh my god, like, it's gonna be, I was seriously.
they sell you a greenhouse, tiny greenhouse project, and you have these little shake ups.
The entire rest of the day.
No bagels, just stick them in there.
Like froyo.
See, that was kind of part of print cards too, is they had essentially like print cartridges that would have nutrients.
Oh yeah, the
giving it the proper nutrients wherever it needs its life cycle.
So like during my lunch break, I'm and just see things
Just
so I told him that okay, like whoever's like working on this house, I want to like come before you can see
yeah, that's
when
we first started, I had
so when she ran,
and then he had
the
he did my name has no idea.
Or after, like, not this week. So we do 2 episodes?
Yeah, that's what we're saying, is getting it on this one. That's literally what he said.
I loved it, and I was like.
But like next week I have to do
Like, way more than I wanted. Anyways, I just get off there, and then, I get a call back from Emily, I'm like, first of all, I'm discussing, like, kind of like 3:30, and I'm like, figured out if they were to visit, so you can
Doing my part to eat all the candy. You can say I didn't eat much.
on it, I was and then I get a call back from her. She goes, so the sellers offered today, and they already accepted. So I'm like, like way overpriced, like way more than what we already got for it. And then the buyers, or then the seller was just like, alright, that's amazing, like, let's just accept it. No, what happened?
So this is a technical one. So you might not know what the stakeholders
Your t-shirt is apropos.
So
Yes,
so my first
I thought about, well, because I pulled it out of the dryer yesterday.
I didn't know
Today or tomorrow.
because I have the only the gas pump price. She might be able to still and so what usually happens.
So you guys, the sellers are like, yeah.
Yeah, so it did, but then so walkthroughs we do that, so that's contractually we'll offer you that.
It would be like end result. Exactly, the same thing what happened with me on the other house, right? And then I go off this car and then I get it.
So then you're gonna do
But maybe they might not like it.
unless you have
Based on
and within a year. Because I don't know, that's been there. I think I'm over.
when the
It's so
final,
hard.
yeah, so
That's why it's
it's
perfect.
right?
I can stay in all 6.
Alright, cool, then I will,
So contact the other real estate agents, say like anything that does the trailer.
I'm extremely interested in contacting Craig Cole. I just think, totally, it is, like, I think it's a California thing, and I think.
Yeah, We're back.
Before we finish, stop beating.
And then I get a call.
Yeah, that's a great color on me.
That's a great color on you.
Long.
I know. Sorry, no.
Like, I'd rather see it like, give it another one. Powder.
I like this color. I don't know. I'll figure it out. Well, they're friends and I love them.
Yeah.
Tell her, like,
It's always the kicker.
Right?
I mean, for making.
You did wear Kennedy Space Center.
Yes.
Did we not get to? I don't know.
Nope. Well, we got the one that says right now, so long ago. No, Kyle, we got the Occupy Mars.
Oh, that was it.
But I guess for one of the state photos we got, it was just like so for one of the drag.
Oh, yeah, that's fun though. It was good. Yeah.
It was on an extra large counter. It still fit.
Well, no, that was the second.
Still fit. No, it fits okay. I'm like on the edge between.
He was fine with his
I'm usually better, but he seems to be in a rush. Or at least I was in a rush.
He does pretty much all, yeah. Brandon's there with both of them.
And I was excited because they had just landed the rocket, and we were at Kennedy Space Center for the SpaceX launch on April 8th.
We're also like so far, like.
I got to watch the launch there. Then went to the gift shop, did all the shopping. Got back on the bus.
I know.
Yeah, so we were like, we went there, we went to Disney World for our honeymoon. We were like, okay, well, we're going to Kennedy Space Center. And then I said, if there's a launch, we'll plan to, if there happens to be a launch. And then they announced that CRS-8 to the space station was going up. And I'm like, well, I don't want to be chasing it. I don't want to go there every day for 3 days. And so then we, but I didn't want to spend $80 every day. Yeah. And so then, of course, it went off like on time, and first attempt, and like, the God smiled upon us. The rocket God smiled upon us. And you talk to some people who have tried to go, and they're like, yeah, no, you'll be sitting there, and then they'll be like, nope, not going up today. No reason. Yeah, there was one where they canceled it. It was supposed to go up at like 5 p.m. and they canceled it at like 8 a.m. that day because the upper level winds, like you look at the wind graph and it was like,
Yeah, he didn't go.
and you're like, yeah, that'll tear a rocket apart. Right?
So you guys are so busy today.
You have to keep it charged. It's not camera.
Yeah, because you put it, just have it on your phone for debugging.
Sorry, if you go to Slack, it'll sign out.
Yeah.
Yeah.
As the property
I'm like, look, babe, I got more free hardware. She's like, oh, good. So we'll sit in the box. And I'm like, yep.
That's for a Raspberry Pi 2, right?
Yeah. Because like the Leap Motion, you know, I've had that for 2 years now, and I have
you've had that for, you were still living together.
Yeah, it was. Because remember we hooked it up out in front on the TV, and the little tiny box couldn't run it.
Yeah.
Well, so remember, I've had mine since Evan got his. So
Yeah, because you pre-ordered it. Yeah. You got it on like Kickstarter or whatever it was.
And of course,
that's a good question. I had hooked it up like 4 times, and I played with the apps on there a little bit, and then decided I didn't get it.
At least with the Raspberry Pi, you can
Yeah, the Raspberry Pi is a little bit more
so
useful
much,
because
that
it's an
requires
entire
so much
computer. Yeah. Not something that there's no taste for, there's no support after for.
it's so beautiful though, like.
Wear it for some reason.
Probably.
Mine's already cool.
I lied, there's no more left.
It's like I don't have one that gets me into buildings anymore.
This will get you out of things too.
Probably I don't want to play that in card. No. Oh, I left my card.
It's not that hard. All you do is
Yeah, I'm thinking of like that one guy on my beard.
The other is yes, my square 4 beer are either.
Yeah.
I will watch the training video.
Yeah. I saw it.
Upper back.
There's
There is about 150. All of it.
Well, the restaurant
That would not be in this book.
Is that where you get the sequel broth plum powder drink?
Really?
Yeah. Yes, that one.
You failed. Oh, honey.
I've only listened to the first half of the audiobook 5 times.
No, you actually make that happen.
Yeah, you can find their
I know.
It takes
I won't make you go,
like
ah!
it's like having your brain smashed out with a brick of gold wrapped around a slice of lemon. Or actually, I just said a slice of lemon wrapped around a brick.
Long vibration.
Yeah. So, yeah, basically you go home and you have to do more work. So you have to do like a 30-second video, and then you get then you get submitted. Then you get submitted to for NASA judging. And if you win that, then you get all access, like VIP pass, or at least this is what it was like 2 years ago, to a NASA launch. but you have to pay your way there, pay for the hotel. But then you end up, like, what if it takes lunch and you can't take it entirely? So you go there. And my brain would be like, that's why I was like, specifically, I don't want to chase a lunch that might
But I
not
like
happen.
how you said, I don't want to go to Space Center food. That fits.
No, I would have gone again for twice to see the Saturn V. Part. That was nice.
I would have taken it for
Right, like I don't really care.
It was very nice. Is it engineer? You find
Yeah.
Well, yeah, we gotta go to all the dances. That's another thing we can do. Joe, I think, used to work for I don't know what he did. The DVD, it sounded like any post an infrared launch of the Spitzer Space Telescope. So I wonder if he worked on that.
I know exactly what
Yeah, so yes, we do.
The only brother I really like.
They're still visible
He doesn't post on Facebook.
I still don't know what I'm gonna do.
No one gets exposed to him.
Funny enough.
Yeah.
Oh,
my brother too.
Before I finalized
Fucking up my brother Brian.
Will not enter the wrong. He won't even do anything. He doesn't do anything wrong. You don't type it wrong. And he'll say, and then I'm like,
She went with Becca to at ATP, fundraising there for KTV. And we were gonna go. And she's like, oh, I need to make sure that I find a programming thing that Brandon can do instead of going to ATP so I can get his ticket.
yeah, right.
Yeah, no, I was
With the online video. Telling your coworkers about Gloria. Like, they were like, oh my god, they were all kidding on her phone. And they're like, no, my phone can't die.
Yeah, right.
I have one you can have.
I guess.
Bye.
Yeah, that's actually the final part of the I know, right?
Twist my
Oh, not tonight.
Email me and say that you would sell my stuff. No problem with killing.
Frank, that's my friend Christine, but she only lets you work for
There's a lot of them.
I know.
That's basically what I've done.
She's in San Francisco right now, and I was like, it's you just go like 3 hours east. It's like a third of the cost of living.
Instead of I'm going to oversee this watch person from this one thing.
Or we're sitting food.
When you just start the roots.
I was down there last night. There was 3 packets.
So there was this one that was
All right, everybody, you can start paying attention again. The interruptions. Yeah.
To hide out?
You can hang out over here. You want?
They want the same.
Yes, just hang out there. Maybe Susan can take a couple pictures so that the judges doing their judging thing.
Not like I think they did a great job.
All right. So we spent our time, due diligence, looking at the projects and the categories. And so the way we're going to do this is we've decided that People's Choice will be Fetch a Rock, and they're going to compete in that category. And then, yes, great job. The main factors were kind of the size, the cross-functional team, and kind of the completeness of the presentation, and obviously the tech was awesome. Don't crash me, bro. Going in for best use of data. We felt that you incorporated the best set of back-end APIs into kind of a coherent whole. So you'll get into that nominated in that category. And then for yes. And the last, so we can nominate into two projects into 2 separate categories, or same category if you will. And so we just picked Canary for best use of hardware, mainly because yes, we felt that as Lauren put it, it seems like a good MVP, and it can be. I think it could be taken rather quickly into the next phase. So that's it. That's what we have to allocate to the NASA level. All projects are have the option to submit their code to the open source initiative that NASA has. I think NASA is going to go through a process of picking whether or not you're accepted. I don't know what that is because they just gave me a one-liner saying new this year. So when I find out more, I'll let you guys know through Slack. And so that's it for the judging and the placement of projects into prize categories. Just want a quick round of applause for all the teams. Everybody did a fantastic job. You guys have any notes, impressions?
I just wanted to personally thank each and every one of you for voting with your feet to hold your hackathon here, not once, but now this is the second time in 3 years. So again, we're profoundly honored. Thank you.
Okay. Awesome. All right.
Our kids want to be you when they grow up. So however terrifying that might be.
All right. So real quick, what's next? You have a week, which I think starts tomorrow, to finish your project listing, get your 30-second video done. and then that'll lock down, although there's some gray area there, but don't say I said that. And have that complete so NASA can look at it, and then within, it's a 30-second video, so you don't get a lot of time, so you got to kind of be concise and on the point. The global NASA judging will be announced a winner a month after the submission period closes, hopefully. Within a week, they get the date on that. So that's something to set your, you're not done yet, is what I'm saying, so you got to finish up. All right, and then quick thank you to Todd and Delamar for giving us the space to work in, and yeah. And if you registered on the spaceappschallenge.org website as an attendee, I will send out a Survey Monkey that'll have all kinds of fun questions. Typically I just ask people, but it's kind of big enough now that I'm just going to automate it. All right, so thank you all. I personally appreciate you all coming out. I think that it's always amazing that I can stand here for like 15 minutes when we start and just say, okay, what do you guys want to do? You guys say we want to do this, you go do it, and I don't have to like tell you what a hackathon is or where to put your code or how to collaborate, any of that stuff. It just happens, right? So it's totally awesome. Yeah. What?
Where do we put our code?
In my pocket. All right, so hopefully you'll be back next year. If it's your first time, obviously it might have been a lot, but you kind of get a feel for how this goes and the spirit of collaboration here, and bring a friend. That's how we've been growing this. So I encourage you to, and as we have a gentleman here who traveled from Sacramento to be part of our event. So we got geographic pull as well.
I'd like to make a couple other suggestions. One is if you know anyone that would like to be a sponsor for next year to improve the program, donate food or prizes, send it to Joe.
Yeah.
Also, any of the content that you would like to see featured on the Space Apps Instagram, Twitter, Facebook pages, tag it with Space Apps Reno or send it over to Joe. But we're curating the content, and there might be some potential publicity around it, so if you're interested in more of that.
Yeah, especially the videos and any kind of, well, the write-ups will be on the Space Apps Challenge website. Just let us know when you have them done, and then we'll get them out there. So, all right, cool. Thank you all.
Thank you.
Yep. Wow.
Is it always like the third week of April?